Hey guys, I have something a bit different for you here today. This is an electronic load by Amrel or American Reliance. I picked it up used. It's got to be about 13 or 14 years old at this point, so it's been around for a while. I'm hoping I can use it in some of my battery capacity tests. The electronic load will take the place of the inverter in my capacity testing setup, and basically it's converting the energy into heat using transistors and large heat sinks and fans to blow it out of the enclosure. Instead of connecting a space heater or some other lamp or something like I've been doing. The reason why this is beneficial is because this will allow me to set a constant current rate. Currently, the way I test batteries is a constant power rate. In other words, I plug in, say, a 60-watt light bulb, for example, and that light bulb draws 60 watts for the entire duration of the test. It doesn't matter if the 12-volt battery is at 14 volts or it's at, 10 volts, end of the discharge cycle. It's still drawing 60 watts. And as a result of that, the current fluctuates dependent on that voltage. Now, almost all battery manufacturers will spec the capacity of their battery at a standard test. And that standard test is usually a standard amount of discharge current. It's typically 0.2 C or 20 amps on a 100 amp hour battery. That said, I thought I'd give this a try, in particular on 12 volt batteries. This is model number PLA800-60-120E. And that means it can handle 800 watts maximum, 60 volts maximum, 120 amps maximum, and that E is a package identifier or features or something, I don't know. I'm certainly not an expert on this device. I've had it for a couple of weeks. I've only used it 2 or 3 times at this point. So I'm going to get a battery hooked up to this. We're going to go through some of the features on the front. We'll do some basic testing. We'll compare it to the shunt on my Batrium that I use for testing. And then of course my favorite part and everyone else's favorite part, I'm going to just open it up and see what's inside for fun. Alright, so taking a look at the front here, as I said, this is the PLA800-60-120E model. We have our voltage display and our current display, both of which have 4-digit precision. We have our operating modes here. CC is constant current, CR is constant resistance, CP is constant power, and CV is constant voltage. We have our on-off for our input. I'm not quite sure what the short button does. I know what the word short implies that it does, but the times I've pressed it, it hasn't done anything, so perhaps I'm using it wrong. We have a step option and we have a pulse option for the input discharging. Over here on the display, we can see it's set for CC or constant current mode. It's set for 5 amps and it's in local configuration mode. This can be configured remotely. We'll go over that a little bit later. This is a rack mount form factor, so it'll fit in a standard server rack or equipment rack, and it's a 2U rack height. We have some options for our pulse mode here: peak, frequency, duty, slew. I'm not going to pretend to know what all of this stuff is. I'm not an expert. I'm still learning this. And then we have a button pad here for some configuration and menu options. Taking a look at the back of the unit, we have our input power. It will take 120 or 240 power. We have a series of what appear to be fan grates, but I don't see any fans installed in them, so I assume it's just an exhaust port. We have some relay contacts. We have an external programming port. You can send commands over this. You can daisy chain multiples of these together. You can have an additional set of wires for your voltage sense and so forth. We have our primary input terminals here. Red is positive, black is negative, obviously. As I've stated before, they're rated for 60 volts DC, 120 amps, 800 watts maximum. We have an Ethernet port. You can actually plug this into your network and control it from a computer. Same with the USB port. The Ethernet port uses the Skippy or SCPI standard, and I was able to control this using a basic telnet prompt and just sending commands over telnet. We have a GPIB connector here. I don't know what that is. I assume it's some sort of integration. And then we have a standard RS-232 serial port. Alright, we'll use one of our favorite batteries. This is the Litime 12 volt 100 amp hour. They're a very basic version. It's an excellent battery. Alright, so I've got my standard capacity testing set up here. It's the Batrium shunt and my Android tablet. I've got a whole video on how this setup works here. I'm connected to the electronic load instead of an inverter. Alright, so we see 13.29 volts over here, and we see 13.35 volts up here, so they are very, very close. And I do see this is showing 0.1 amps here, so I'm not sure. This is supposed to be calibrated, but like I said, it is about 13 years old. So I want this on constant current mode. I'm going to press the CC button. Okay, I'm going to come over here to the settings, going to press the settings button. And now we see the main and the amperage is flashing. So I can type in 20.0, press enter. And now we see it's on constant current mode, 20 amps, local configuration. As I showed you earlier, there are communications ports on the back, Ethernet, USB, and RS-232. If you were to program it with one of those ports, this would no longer say local. I'm not sure what this auto mid 120 amps means. I haven't looked that up just yet. I suspect that might be the current limiting there, or the safety. And I do see the current has dropped to 0.08, so perhaps this is just negligible. Anyway, now that the settings are dialed in, we can go ahead and press the input start here to start the test. And we see the E-load is now putting a 20.04 amp load on the battery. And our Batrium is showing 20.02 amps. So man, that is close. That is two hundredths of an amp difference. So we should be able to stop that test by pressing the same button. And let's say we want to run a 50 amp test. Press the settings, we'll enter 50.0, enter, and press start. So now we're pulling 50.04 amps, and our Batrium is reporting 50.11 amps. Now I do see there is a bit of difference in voltage here. We have 12.87 volts and we have 13 volts. It's not that much different. However, this is where that external voltage sense lead off that rear contact would come in handy, because it would bypass any voltage drop in this cabling, and it would bypass voltage drop across the shunt and across that fuse up there when measuring the system voltage. I don't think the voltage matters for this constant current test, because this E-load does not have a low voltage cutoff like an inverter would. So this will run down to, it's very close to 0 volts, I believe. It'll continue trying to put this 50 amp load on. It's not like a 12 volt inverter where your voltage drop across the cables causes the inverter to see 9.5 volts, and the inverter isn't like that, so the inverter shuts down. This test should be able to run this battery down entirely until the BMS in this battery shuts off. And that should be the point at when we determine our final capacity. So it's been running for a few minutes here, and again we're at 50.04 amps and 50.11 amps, so there is a little bit of variance. This is technically considered a scientific instrument, so I would expect it to be perfectly calibrated. Again, it's 13 to 14 years old. The Batrium has been calibrated, but it's not a scientific instrument, so I don't know how precise that actually is. But either one of these numbers is going to be perfectly acceptable for the purposes of my capacity testing. Alright, so let's do one more test here. Let's say I want to run a constant power test of 700 watts. This is 800 watts limit, so let's do 700 watts and just see what it does. So I'm going to switch it to the CP, or constant power mode. I'm going to come over here, press the adjustment button. I'm going to enter in 700 watts, 0.0, and press enter. So now we're set for CP, constant power, 700 watts, local. And I'll go ahead and press the start button. Alright, so we are discharging at 54.3 amps. That's what it's calculating to be 700 watts based on this voltage. And we can see on our Batrium display up here, it's calculating that at 708 watts. And for fun, let's just see if it can do something as low as 10 watts. 10.0. I'm not sure what the low cutoff actually is, and start. And we have 0.72 amps, and the Batrium is showing 9 watts. Pretty cool. You can get very precise tests with these things. Alright, there's a lot of stuff going on in this chassis. Some of these components I'm not even sure what their intended purpose is, but let's take a look at what I've been able to figure out. So our AC power comes in the back left here. Cables run up the front, and you can see the on-off switch down here. From that, the power goes into this circuit board, and a second line goes into this circuit board. So this appears to be the power supply for the whole case. You can see a larger set of black conductors coming out. And this power supply appears to only be for the fans and maybe one other circuit. So the lines coming out here, we have a series of positive and negatives that go up to this array of fans. And then we've got this white conductor that goes somewhere else. So this white conductor might actually just be a control signal, I'm guessing either for the fan speed or for turning the fans on and off, because they don't sound like they're on all the time. On the right hand side, we have 3 PCBs or printed circuit boards. There's a stack of 2 of them here. Second one under there. There's one over here. I just assume that's the computer of this thing. Again, we have our wall of fans. They appear to be standard 80mm computer fans here. So down here, this is a very large aluminum heatsink, runs the whole width of the enclosure here. And it's probably, I don't know, what's that, like 8 inches or so deep. So we have 8 of those transistors, and then we have 8 empty space where they could have soldered in more transistors, and I assume that's done on the 1500 watt model. Again, this is only the 800 watt model. Taking a look at the back here, this is our main negative and this is our main positive. We can see that negative comes up to the side here, and we have a shunt. This is going to be the shunt. And then this is the board measuring the voltage on both sides of that shunt, which is then used to calculate the voltage drop. And with that voltage drop, we can calculate the amount of current. And then we have some circuitry down under there for our communications ports. All that runs back over here to the computer boards. So one thing I noticed is how these conductors are twisted together and nicely bundled. I mean, they are perfectly routed. You certainly don't see this quality of work in electronics these days, especially not in the consumer market. Now this is fairly old. Some of these components, for example, if I look at this board here, it says April 9th, 2009. If I look at this board over here with the transistors, it does say June 9th, 2008. So like I said, this is several years old. It certainly isn't new. Interesting bit of information here. This main positive lead is attached directly to the heatsink. And then that heatsink is isolated from the case with a ceramic insulator on both the left and the right hand side. All right, I think we'll call it quits here. I am very excited. I'm very excited to do some capacity testing with this electronic load. I've already worked out an entire process for it. It's been several days since I filmed the first half of this video. So I have a process worked out to test batteries without the Batrium. I've already written scripts that will gather data from that Ethernet port. I've written scripts to generate charts, graphs, all kind of statistical information. All I need to do yet is build a new Grafana dashboard to use. I'll talk about all of the capacity testing ideas in a separate video. I'm going to link to where I purchased this from, the eBay store I bought it from. They also have an actual website if you want to check it out. It is ecrunch.com. I'll leave links down in the video description. Amrel does make larger versions of this, all the way up to 7,500 watts, I think. There's a 1500 watt version, there's a 3000 watt version that I think is a 3U chassis. I'm going to see if I can get my hands on one of those for the right price. The 3000 watt version was selling around 3,500 when I checked last. That is a little bit pricey for me. Just for the sake of capacity testing, but I'll see what kind of deals I can find out there. I'm very excited to put this thing to use, so check back soon for the capacity testing video, and then the subsequent video where I'll actually capacity test a new battery. The first test will probably be that dumb fume battery, whatever it was called, that budget battery that I bought over the Black Friday holiday. So yeah, any questions or comments, let me know as always. Hit that like button before you go, and thanks for watching.